Hi guys, welcome back to the channel. So today we are going to be looking at the weekly contest third question, which is minimum operations to make the median of array equal to k. So we are given an integer array which is going to be nums, and then it consists of all the numbers which are present in the array, and then we are going to have k equal to some variable which is non-negative integer, and then we need to make this particular median equal to k equal to 4. So we need to make minimum number of operations that we need to make on this particular array, and then it should be equal to that particular median of nums should be equal to k. So in one operations we can do two things. We can either increase some particular element, or we can decrease some particular element, and then we need to return the minimum number of operations that we need to make uh, to uh, to make this particular median of nums equal to k. So let us see some particular example where we have 2, 5, 5, and then 6, 8. So for this particular nums, we need to make the median of this particular array to 5. So the array can be either in decreasing order, increasing order, or it is in any order. So that's why we are going to sort this particular array, and then we are going to get that in particular order. And then we are going to calculate the middle element. Suppose let's say middle element is equal to k, then we do not need to make any operation on this particular array, and then we are going to return 0. So there can be another case where k is will be greater than this particular median, which is going to be 5. So for this particular case, we need to only take care of the elements which are in the right of. Suppose if we increase this particular element to 7, and then here again will increase to 7, then this becomes 7 and then 7. Why we should increase to 7? In the sense, this is going to be median, and then if I don't increase this particular 6, then 6 becomes median. So we need to increase all the elements which are less than 7 in the right of, so to 7. So that's why we are going to have the operations for this, uh, which is 7 minus 5 for the middle element, and then 7 minus 6 for the next element, which is going to be 2 plus 1, which is going to be 3 operations which will perform for this particular order. And then let us consider for this k equal to 3. So for this particular k equal to 3, we have 5. So for 5, we need to decrease this particular 5 to 3, and then after decreasing to 3, if we do not decrease this particular 5 to 3, then this becomes the middle. So that's why we are going to decrease this to 3, and then again this to 3. So for this, the number of our operations is going to be 5 minus 3, and then again 5 minus 3. So this is going to be our answer, which is going to be 2 plus 2, which is going to be 4. That's what we are going to do. So let us go through the code. So we'll be taking all different possibilities. So first we are going to sort this particular array, and then we are going to get the nums dot size equal to n, and then we are going to calculate the answer. Suppose let's say the middle element is going to be k. That means we do not need to do any operations, and then we are going to return 0. Suppose let's say this particular middle element is less than the k, which is this particular case. For this we are going to consider the right of, and then in this particular write-off, whenever the nums of I is less than k, that means we are going to increase it to k. The number of operations required will be k minus nums of I. And then whenever the nums of I is greater than or equal to k, then we do not need to do any operations, and then we'll break out of the loop. And then there can be another case where we have nums of I will be greater than k. For this, we are going to consider the left of. So for this left off, we are going to start from I equal to n by 2, and then we'll decrease this to I minus minus till I greater than or equal to 0, or this particular nums is greater than k. Then for this we are going to decrease it to k. So for decreasing it to k, we are going to do these many operations to decrease by 1 by 1, and then we are going to add it to answer, and then at last we are going to break out of the loop, and then we are going to return the answer. So for this, if we come to the time and space complexity, the time complexity is going to be big of n. and then space complexity is going to be big of 1. Yeah, that's all for this video. Thanks for watching the video.